Hello, this is the Math Dog here. This video goes over graphing a linear inequality in the XY plane. I'll call it part 1. There's going to be a part 2 of this video. So, based on Common Core, I'm putting this as a grade 8 topic, although this should be also reviewed or gone over for possibly the first time in an Algebra 1 class. So again, this video is not to be shared or reproduced without the written consent of the creator. That would be myself, the Math Dog. So, first of all, inequality signs and how to interpret them. The sign that's pointing to the left here means less than, so the number on the left is less than the number on the right. In this situation with linear inequalities, it'll be represented with a dashed line. The next inequality sign is less than or equal to. It is represented by a solid line. In this application, the greater than sign, the number on left is greater than the number to the right. The number opens to the larger. The sign opens to the larger number and points to the smaller number. This is greater than, it's represented by a dashed line. And then greater than or equal to is a solid line. So in this video I will refer to half planes. A half plane is simply, so you have the XY coordinate system here. You can't see my X and Y axes. Doesn't really matter. So you've got, this is like a two-dimensional plane or like a tabletop that goes forever in all directions. Okay. But if I put a line there, a line goes forever. And this line that I've drawn here will separate this two-dimensional tabletop or plane into two different parts, and we call each of these a half plane. So like Roman numeral 1 here is one half plane, Roman numeral 2 is a second half plane. So that's what a half plane is. It separates the XY coordinate system, the grid, or the XY plane into two parts. So in this first example, I am going to graph the solution to y greater than negative 9 halves x minus 5. Now that's a greater than sign, so we're going to use a dashed line here. So the first thing I want to do though is I want to take out that inequality sign for a moment, and I want to write what I call the boundary equation. So replace the inequality sign with the equal sign. So now I'm going to graph this line that will be dashed. So my y-intercept, remember this is of the form y equals mx plus b. B is your y-intercept, m is your slope, so the y-intercept is negative 5. Slope is negative 9 halves. So I'm going to go over 2 to the left. So I'm going to do it this way, 9 over negative 2, because that's the same as negative 9 over 2. So I'm going to go 2 to the left and 9 up. Here's my second point. Now I'm going to draw a dashed line. And for the exercises at the end here, you will need a sheet of graph paper. So I'm going to try to draw this. I'm going to have to fix this line because I got it way off here. But let's do this. So this is my boundary. So that's step 1. Okay, step 2 is to take a test point that is not on the boundary. Well, the easiest test point here that is not on the boundary is the origin 0, 0. So I take 0, 0. Now, if 0, 0 was on the line, you cannot do this. But it's not. So I take this point, plug it into the original problem. So replace y with 0, replace x with 0, and determine is this true or false. Well, 0 is greater than 0 minus 5, so that's true. So since this is the test point is in the right half plane, we shade in that direction. So the solution to this is all these points here shown in red. It's this entire half plane, everything except that boundary line, because the boundary line is dashed. It means that is not included in the solution. So for example, a solution to this, let's take right here, 3, 4. Notice that 3, 4 will make the inequality that we started with true. So we had y greater than -9/2 x minus 5. If I plug this point in, because it's in the solution set, it should make it true. So y is 4. So 4 is greater than -27/2 minus 5. That's certainly true because that's a negative number. So any point here in the right half plane will make this inequality that we started with true, and that's part of the solution set, which we represent by a shaded area. Okay, next, y greater than or equal to 2x minus 3. So that's going to be, because it's greater than or equal to, it'll be solid. Let's first write the boundary equation, y equals 2x minus 3, replacing greater than or equal to with equals. So the y-intercept here is -3, the slope is 2, so 2 slope at 2 is 2 over 1. So I go over 1, up 2, over 1, up 2, over 1, up 2, draw a solid line through there. Okay, and again, notice 0, 0 is not on that line, so I can use it as a test point. So test point, I'll use 0, 0. So 0 greater than or equal to 2 times 0 minus 3, 0 greater than or equal to -3 is also true again. So the test point this time is on the left though, so I shade to the left. So it's all these points over here in this left half plane, they make the solution to the problem. And this time, because it's solid, the solution includes the boundary line itself. Again, we could take a point, let's take this point here, -8, 3. That should make the inequality true, so let's just demonstrate that. So our inequality was y greater than or equal to 2x minus 3. So we have 3 greater than or equal to 2 times -8 minus 3, 3 greater than or equal to -19, that's true. So that is a solution to that original problem. Okay, next, we have y less than -3/2 x plus 2, that's a less than, so it's dashed. Let's take, now rewrite it as an equation, the boundary equation. So now let's take a test point in a moment. First I should plot this, so the y-intercept is 2, up 2 from the origin. And the slope is -3/2, so I'm going to go over 5 and down 3. And I could keep doing that. And I could go back 5 and up 3. Okay, let's put a dashed line through there. Okay, now again, once again, this does not go through 0, 0, so I can use that as a test point. Okay, so let's plug that in. 0 less than -3/5 times 0 plus 2. Well, that's 0 less than 2. Once again, that's true, so I'm going to shade the left half plane. That is the solution. Includes everything except over here on the left half plane, except the actual dashed line, because that is an inequality. It's a less than, it's not a less than or equal to. So the solutions go right up to the boundary but do not include it in this problem. So now let's plot x greater than 0. That's going to be a dashed, because it is greater than. Okay. The boundary equation is x equals 0. Now that is not a normal line y equals mx plus b, that has to be a vertical line where x is 0 everywhere. So it's got to be a dashed line that is actually the y-axis, because this is the line that is x equals 0 everywhere up and down here. So let's do a dashed line. Alright, so now I can't use 0, 0 as a test point because it's on the line. So I can't use it, so let's just use this one, 1, 0. That's not on the boundary, so it's very easy here. So x is 1, and there is no y coordinate, so you don't worry about it. So the inequality is 1 greater than 0, that's true, so we shade, because this makes it true, we shade to the right. And the solution is all this shaded area except the boundary itself. All the solutions go right up to the boundary but do not include the boundary. Okay, now we have y less than or equal to -1. Okay, so less than or equal to is solid. Okay, the boundary equation is y equals -1. Remember, that could be written as y equals 0, x minus 1, where the y-intercept is -1, slope is 0, it's a horizontal line that's solid. Like that. Okay, that's the line y equals -1. Alright, so now let's take a test point. We can use 0, 0 this time. So let's plug it in. Well, there is no coordinate for x here, but y is 0, so 0 less than or equal to -1. That is false. So when it is false, the test point's over here, we shade on the opposite half plane. So our solution is down here this time, because the test point gave a false result, and the test point's located here in the upper half plane, so we shade the lower half plane. So it includes all these values here and includes the boundary line here because it is less than or equal to. So let's summarize how to graph the solution to a linear inequality. First, determine if the boundary line is solid or dashed. 2, write the inequality as an equation. Replace the less than, greater than, less than or equal to, or greater than equal to sign with an equal sign. 3, solve the equation for y. It should now be in the form y equals mx plus b. Draw the line by first plotting the y-intercept, then construct some points using the slope to guide you. The only exception to this is in parentheses, the only exception to this is a vertical line, which will be of the form x equals. 4, find a test point not on the boundary line. It cannot be on the boundary line. Plug the coordinates into the original inequality. A, if the test point makes the inequality true, shade the half plane on the side of the test point. B, if the test point makes the inequality false, shade the half plane on the side opposite the test point. Right, now I want you to stop the video and solve that inequality. Then turn the video on and see if you get what I do. Okay? So first thing here is I would probably, if I was you, I would put a 1 there. That's -1x minus 4. So y greater than -1x minus 4. I just put a coefficient of 1 to remind myself that is -1. The slope is -1. Second, replace that inequality sign with an equal sign. This is your boundary equation. Then plot the boundary equation. The y-intercept is -4. Slope is -1. So I go over 1, down 1, over 1, down 1, over 1, down 1. I could go back 1, up 1. This is a dash line. Okay, there's my boundary. Now take a test point. You can use 0, 0 because it's not on the boundary. Plug that into the original problem. Y is 0, x is 0. So we get 0 greater than, that's 0 minus 4, that's -4. That is true. Therefore we shade in the upper right-sided half plane. So the solution is all these values here, not including the boundary line because the boundary line is dashed. Okay, then do this problem. Graph the solution to y greater than 1/2 x minus 2. Y greater than 1/5 x, 1/5 of x minus 2. Stop the video, solve this on your piece of graph paper, and then you can turn the video on to check see if you did it right. Okay, so this is a dashed line. Greater than is dashed. Write the boundary equation, y equals 1/5 x minus 2. The y-intercept is -2. Slope is 1/5, so I go over 5 and up 1. Over 5, up 1. And I could go down 1, back 5. And I'm drawing a dashed line through these. Okay, notice again 0, 0 is not on the line, so the boundary, so I can use it as my test point. So plugging it into the original inequality, 0 greater than 1/5 times 0 minus 2, that means 0 is greater than -2, that is true. Therefore, since the test point's in the upper half plane, I shade the upper half plane. And that is my solution. And this concludes the part 1 video.